Hello, everyone. Mr. Minnick's my name. Math is my game. So, we're looking at complex numbers here in this eighth section of Chapter 4. The homework exercises really, I kind of said it in class the other day, they go from zero to hero pretty quick. If we look at this first exercise, make it a little bit bigger here for the whole world to see. Number 4 says, let's simplify the expression. Simplify the expression. Really all we've got is two different complex numbers, and we're finding their difference in this case. We're just combining like terms. So we have 4 minus negative 3. That's going to give us 7. And then we have negative 2 take away, negative 2i take away I. So negative 2i take away 1 more. That's going to be minus 3i, and that's it. Number 4 was that easy. Okay? That easy. 4 minus 3 is 7. Negative 2 minus positive i's minus 3i. Moving on to number 8, it says simplify each number by using the imaginary number I. So number 8, what you realize is that the square root of negative 4 could be written as the square root of negative 1 times 4, or the square root of negative 1 times the square root of 4, which would be I times 2, and we write that as just 2I. All right? So number 8, we're looking for 2I, and that's it. Number 12 is similar, but 12, we got 50 this time, and hopefully you remember simplifying radicals. So 50, we're going to break that down. That's going to be the square root of negative 1 times 25 times 2, right? Because 50 is 25 times 2. So then that's going to be the square root of negative 1 times the square root of 25 times the square root of 2. So an I pops out, a 5 pops out, and I'll add 2. So 5I square root 2, 5I square root 2 is what you should have had for number 12. Hopefully you're doing all right with those. Number 16, it says plot and find the absolute value of 1 minus 4i, 1 minus 4i. So remember, when we plot this, we don't need anything special here. Just remember the x-axis is the real axis, the y-axis is the imaginary axis. So if we examine the real component, the real portion is 1. So on the real axis, we go to 1. That's 1 unit to the right. The imaginary portion is negative 4. So on the imaginary axis, we go down 1, 2, 3, 4. So when we plot that point, let me use a special marker here. I'll use a creative pen, and I think I will use a smiley face. So when I go to plot that point, then it's just going to be from what we think of as the origin over 1 and down 4, and there it is. It's down in what we think of as the quadrant. And we're asked to find its absolute value. If you forgot the formula, you should write it down. The absolute value of a complex number is the square root of the real part squared plus the imaginary part squared. So in this case, the absolute value of 1 minus 4i is the square root of 1 squared plus negative 4 squared. And sometimes you can get to the answer by accident. Either way, when you square 4, it's going to be 16 if it's 4 or negative 4. So we're going to have the square root of 1 plus 16, square root of 17, and then that's it. You don't need to break that down any further. Please don't use a decimal. That's it, square root of 17. Okay, so that takes care of the front half. Not too bad so far. Not too bad so far. Okay, flipping the page over to the back side. Number 20 should have been pretty simple. 20 is a lot like number 4 was in the fact that we're just combining our like terms. 7 has nothing like with the real part, but 9i plus negative 5i is going to give us plus 4i. So 20, you should have simply had 7 plus 4i. All right. 24, I'm going to go ahead and put that on a fresh page. 24, when you FOIL these things out, keep in mind what's going to happen is you're going to have some real stuff out front, and then you're going to have some imaginary things going on in the middle, and then on the end, you're going to have what seems to be imaginary but is actually going to become real. Okay? So the deal is the imaginary terms in the middle, they're going to kind of get put together. This stuff over here on the end that you think's imaginary is going to become real, and it's going to get combined with that. You'll see. So we FOIL, and we get -6. And we do the outer product, which gives us -18i. And then we do the inner product, which gives us -5i. So in the middle, remember I said in the middle, these are going to converge. -18i take away 5i, that's going to be -23i in the middle. Or actually, that's our imaginary part. Okay. Keep in mind with this, the format of a complex number is the real part followed by the imaginary part, a plus bi. That's where we're trying to go with this. Okay. So the last product is tricky. This is where weird things happen. The last product is going to be -18i squared. But what you've got to remember is this. I squared, we said, I squared is really -1. So that last term then is going to be -18 times -1, which is going to become plus, that's going to become plus 18. And the deal is -6 and 18 can be combined, if I'm not mistaken. Where did I get 18 from? That's supposed to be 15. I'm sorry. That's my bad. That's going to change us a little bit. So that's -15i squared. So that's -15 times -1. So that's plus 15. There we go. That's way better. That's way better. So the difference in when we combine the 15 with this -6, -6 plus 15, that's going to give us 9. Okay, so our answer here is 9 minus 23i. The beauty of these, even though it's not so beautiful for Wednesday's quiz over this, but the beauty of these is the calculator does these. Let's take a look. The group of -6 minus 5i, -5, remember I have to use the right I, the proper I, it's located on the pi button. So we have that times the group of 1 plus 3i. And there you go. Whoa, I think I did something wrong. Yeah, I did something wrong. I forgot to quantify the quantity. I forgot to put parentheses around this. If you forget parentheses, it's kind of a big deal. There we go. Okay, so 9 minus 23i is what we were looking for. So that's 24. If you got that one, great job. 28. 28 and 32, not going to lie. 28 and 32 are kind of nasty. 28 and 32 are kind of nasty. So the deal with 28 is we've got a real part in the bottom, and we can't have that. Remember, we're trying to get something of this form. Okay? Not allowed to have an imaginary part in the bottom. So if you missed yesterday, we got to multiply by 1, which doesn't change the value of the expression. But if you missed yesterday, we talked about complex numbers and their conjugates, and we said when you multiplied them, that you're going to get a squared plus abi minus abi minus b squared I squared. The ABI's cancel, so that's a squared minus b squared times -1, so that's going to be a squared plus b squared. Moral of the story is, here we're going to multiply by 1 minus I over 1 minus I. And in the denominator, if we follow that formula, we're going to get 1 squared plus 1 squared, which is 1 plus 1, which is 2. So we're going to get 2 in the denominator. Okay. Well, that little formula is pretty handy. Yeah, it is. Make sure you know it. The numerator just requires a simple distributing. So -2i times 1 is -2i. -2i times -i is going to be plus 2i squared. Don't forget, I squared is -1. So what we're going to get then is -2i plus 2 times -1. That's still all over 2. So that's going to be -2i minus 2 all over 2. Now that's not in the right form yet. Remember, we're trying to get it into the form a plus bi. So I'm going to kind of switch things around a little bit. I'm going to write that as -2 minus 2i over 2. And now what I got to realize is, I still don't have it in the right form. I've got -2 over 2. And then I've also got -2i over 2. I don't know why my smartboard keeps messing up in this particular area. I'm going to have to clean it. So when we clean that up, what we end up with then is -1 minus I. That's your final answer. That's what you should have had on this one. I know that one was tough. Hopefully there's a couple like that in the Math Excel homework that you can practice for more practice. So that's -2I over the group of 1 plus I. So that's -2, I said that's -2I over the group of 1 plus I. So again, the calculator, it will do these for you, and there you go, -1, take away I. Okay, that's what you should have had. And I know you're thinking, oh, but wait, well, let's look at the steps again from the beginning. So, taking a look at it again, the first step is to multiply by the conjugate. Multiply that by the conjugate over the conjugate. Okay, when you do that, we're going to get 1 squared plus 1 squared, which is 2 in the denominator. Up top, we distribute. -2I times 1 is -2I. -2I times -I is going to be positive I squared. I squared is -1. So the -2I is kind of going for the ride. 2 times -1 is going to become a -2. 2 times -1 is going to become a -2. So that's -2. And then I switch the order up just to get it in the right form. I flip the order of the things in the top. And then I split it up into 2 fractions, and there you go. Okay, and then I simplified them. So, not going to lie, that one was tough. That one is tough. So is 32. 32 is tough as well. 32 is tough because, boy, oh boy, the denominator needs expanded before we can even think about cleaning it up. So 32, we're going to have 3 plus 2I over 1 plus I, the quantity squared, or 1 plus I times 1 plus I. Now, at this point in your careers, mathematically, a lot of people want to say that 1 plus I, the quantity squared, is 1 squared plus I squared, or 1 plus -1, or 0. No, no. There's no such luck. A plus B, the quantity squared, is not simply A squared plus B squared. Okay? A lot of people want to make up their own rules. Don't make that up. It's not a real rule. Please don't do that ever. Okay? We got to expand this out. When we expand this out, the top's not going to change. The numerator is going to stay the same. Now the denominator, remember like that one before, we're going to have some things on the ends here and here that are going to need to be part of our real part. So anyway, we're going to get a 1. In the middle, we're going to get plus I. And then we're going to get plus I again. And then on the end, we get plus I squared, but that's going to be plus -1. So when we combine those are going to cancel. So what ends up happening here is this cancels out with this. So we're left with 3 plus 2I over 2I. The problem with that is it's not in the right form. Remember, the proper form is A plus BI. Remember, we're not allowed to have I's in the denominator. Okay? So in the notes yesterday, in the examples yesterday, on one like this, the trick here is to multiply simply by I over I. Okay, that's like multiplying by 1. It's not going to change the value of the expression, but it is going to make something cool happen. So we're going to get, when we distribute, we're going to get a 3I plus 2I squared. Hey, but 2I squared, yeah, hold on a minute. We'll take care of that I squared. In the denominator, we're going to get 2I squared as well. Okay, so we're going to have 3I plus 2 times -1 over 2 times -1. So we're going to get 3I minus 2 over minus 2. So we're going to get minus 2 plus 3I over minus 2. Minus 2 over minus 2 is going to become just -1. And 3i over negative 2 is going to be minus 3 halves I. So that's the final answer. That one, again, is a mess. Okay? A lot of steps involved in that one. What did you do? Okay, let's look at it again. It's all the steps. What did I do? I expanded. I simplified that expansion, and I got just what in the denominator? Just 2i squared. But wait a minute. But 2i squared, well, actually, it was just 2i, right? Yeah, it was just 2i. And then I multiplied that by I over I, and then I got 2i squared, 2i squared. Replace the I squareds with negative 1s. Cleaned it up a little bit. And then I had two fractions, and I had to simplify it and put it all in the right order. So there you go. Wow. Let's see if the calculator would have done that one. 3 plus 2i. 3 plus 2i. So the fraction 3 plus, I said the fraction, 3 plus 2i over 1 plus I, the quantity squared, over 1 plus I, the quantity squared. There it is. All right. I know we really don't like those kind. Do need to be prepared for one of those on the quiz. Okay. 36. 36 requires a little trick. It says factor this. Well, this is a difference of two squares, and you say, but it's a sum. Yeah, it is a sum, but we can make it a difference of two squares. We're going to write it as x squared minus negative a fourth. So then that's going to be x plus something and x minus something. X plus and minus what? Well, what's the square root of negative a fourth? Square root of, an I pops out. You're right. And what's the square root of a fourth? The square root of 1 over the square root of 4. So that's 1/2. So it'll be x plus 1/2 I, x minus 1/2 I. There you go. That's 36. That's how that one goes. 40 wants us to solve. I'll be honest with you. On 40, I'd probably use the quadratic formula, even though I don't like it. 40, I'll use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The problem with I don't like with this is when I get that negative 6 in the denominator. So it's going to be negative 1 plus or minus the square root of 1 minus 36 all over negative 6. So that's going to be negative 1 plus or minus the square root of negative 35 all over negative 6. So that's going to be negative 1 plus or minus I times the square root of 35, and that's all over 6, and it's a negative 6. So the deal is this negative here cancels with that negative there. So really, if we wanted to give the best answer, it'd be 1 plus or minus. Actually, minus or plus, but it's the same thing as plus or minus. So 1 plus or minus I rad 35 all over 6. Okay. So that's what you should have had for that one. Negative b plus or minus square root b squared minus 4 ac divided by 2a. Okay. Looking at the next one, number 44. Number 44, I'm going to use completing the square, if you don't mind, just because I'm good at it, just because I like it. But before I can do that, I need to put this into the right form. I do need to distribute. That's going to be 2x squared minus 6x, and that's going to equal negative 5 still. I'm going to leave it like that, but I am going to have to factor the 2 out. So that's going to be 2 times x squared minus 3x equals negative 5 halves. Okay. Now, the 2 doesn't impact my solution. I'm going to go ahead and remember how to complete a square. I'm going to add the square of half the coefficient of the linear term to both sides. Now, when I add that amount on the right side, I'm going to rewrite it as a more simplified version of that. Negative 3 halves squared is 9 fourths. And negative 5 halves is really negative 10 fourths. So that's just going to speed up the whole process a little bit. So my binomial squared is going to be x minus 3 halves, the quantity squared. And then on the other side, I'm going to get negative a fourth. And remember why we used completing the square, so that we can take square roots. So we're going to get x minus 3 halves equals plus or minus 1/2 I. And keeping in mind that the form for a complex solution, or for a complex number, the way I'm going to write my answer is this. I'm going to write x equals 3 halves plus or minus 1/2 I. Okay, plus or minus 1/2 I. I'm going to go ahead and write my answer that way, just because that's the proper form for complex numbers. Okay, so in solution set notation, we'd have 3 halves minus 1/2 I, and then we'd have 3 halves plus 1/2 I in solution set notation. Okay. So you might be asking yourself, could the calculator do that? Well, let's see. Let's see. Why'd you put the little c out front? Well, if I don't, then I wouldn't do it. So I had 2x times, what was it, x minus 3. And that equaled negative 5. And I'm going to find the polyroots, and it says invalid multiply, invalid implicit multiply. So I got to put the times there. Augment, use a polynomial in expanded form or in one variable. Okay, so it didn't like that. Oh, because, yeah, okay. So that's going to be 2x squared minus 6x plus 5. Okay, there it is. There it is. But that's cheating. Well, that's why you're not allowed to use those on the quiz. Okay. But you will have a quiz where you are allowed to use it too, or a test. So that takes care of 40 and 44. 48, maybe you multiplied all the coefficients and you got negative 288. And then you multiplied all the variables and you got I cubed. Remember, I to the first is just I, or the square root of negative 1. I squared is negative 1. I cubed is negative I, and I to the fourth is 1. So the deal is we replace I cubed with negative I. So that's negative 288 times negative I. So the answer you should have had is 288I, 288I on 48, okay? So what was that? 8I. So it's a group of 8I times the group of 4I times negative 9I times the group of negative 9I. Remember, you got to use the proper I on the calculator. There it is, 288I. Okay. And finally, the last one, 52. You just do a little bit of housekeeping, and then it's like what we saw at the beginning, 8 minus I minus negative 3 plus 4I. So our like terms, 8 minus 3 is going to be 11. Why 11? Aren't we foiling? No, we're not foiling. We're subtracting. We just combine like terms. And then I have minus I minus 4I. That's going to be minus 5I, and that's it. 11 minus 5I on that one. Okay. So that's it. It's been real. It's been fun. Hopefully, you made sense of these. Hopefully, you got most of them. Math Excel homework, get on, try that. Be sure to know how to handle something like 28 or 32. And I'll see you next time. Good.